Good evening, viewers. Welcome to Noble UK Academy. Like I do say, it is an academy of global academic scholars. For some time now, we've been dealing or dwelling on calculus. I know I've touched some aspect of differentiation under calculus. I've touched some aspect of integration under still calculus. Today, we want to look at some aspect of limit. Like I do say, calculus is made up of two main branches. Which are differentiation and integration. But you cannot successfully talk about each of these two without referring to limit. So invariably, we can say calculus is made up of three branches, but two main branches. So this evening, I'll be thrashing some questions on limit. But before then, I would like you to subscribe to my YouTube channel, okay? And by the time I'm done dissecting this on the board and you find value in that, it is expected that you air out your view by commenting on the video. If you find value there, you could just send in your comment on what you feel about what I've taught. And if you have questions to ask, you can equally feel free to do that. Don't forget to share the link of my YouTube channel with other students out there. That is the only way you can support me. Thank you. So this evening we want to see, some students, when they see this kind of question in an examination, they will feel that the examiner wants to murder them to death. But it is not true. These are simple things you can walk through or walk over in an examination hall. Now, let's play with this. Solution. We have, the question says, find the 3 raised to the power n plus 1 minus 5 raised to the power n plus 1, all divided by 3 raised to the power n minus 5 raised to the power n. As x tends to infinity, that is to say, as x becomes infinity, this should be n, not x. Sorry, this should be n, not x. As n tends to infinity. Okay, thank you. So first thing first, let's looking at this. Of course, you should know that when dealing on calculus, you must employ your knowledge of indices. Like I do tell my students, you mustn't do well in calculus, and you won't do well in calculus if you don't have adequate understanding of indices, because you need to employ your knowledge of indices in order to excel in calculus. So you must be knowledgeable in indices in order to have adequate understanding of calculus, be it differentiation, integration, or limit. Yes. Now, I will employ my knowledge of indices here. 3 raised to the power n plus 1 is as good as saying 3 raised to the power n times 3 raised to the power 1. Of course, this is multiplication of indices. So coming here, I have minus 5 raised to the power n, of course, times 5 raised to the power 1. That is what this will give you. All over 3 raised to the power n. This is 3 minus 5 raised to the power n. Okay. So once you have succeeded in carrying out this. We are good to go. Okay, now with this, I will say let's multiply both. I can decide to go by this. Let's multiply both numerator. These are your numerator, these are your denominators. Let's multiply both the numerator and the denominator by the inverse function of 5 raised to power n, and that will be what? That is 1 over 5 raised to power n. That is what that means. So I'll say multiply through, multiply, this marker is failing, multiply both numerator and the denominator by 1 over 5 raised to power n. 5 raised to power n. That is n. This is n. Okay. Yeah. So if that being the case, I'm gonna have, don't forget we are multiplying it by, I'm gonna have 3 raised to power n multiplied by, of course, 1 over 5 raised to power n. Then I have here times, okay, 3 times what? Everything again will be multiplied by this. Okay, so what I'm left here is 1 over 3. Okay. Sorry, 3 raised to power 1, not 1 over 3. 3 raised to power 1. Then minus, what I did here now is also what I'm going to do here. Minus 5 raised to power n multiply, just like what I did here, 1 over 5 raised to power n. Okay, then multiply by what? 5 n over 5 raised to power n. Okay, that is for this. We move to this. Minus this 5 raised to power 1 is something as 5. Okay, then 5 raised to power n times 1 over 5 raised to power n, that would be 5 raised to power n over 5 raised to power n. Dot means multiplication. This times is something as this dot. Okay, then all over this times this will give me 3 raised to power n over 5 raised to power n. Then minus this times this will give me 5 raised to power n, okay, over 5 raised to power n. Now, at this juncture, you apply your limit. We'll be told that n tends to infinity, meaning that any place you see n, you substitute it for infinity. So I have 3 times 3 raised to power infinity. This is infinity. Okay, over 5 raised to power 5 raised to power infinity. Okay, minus 5 times 5 raised to power infinity over 5 raised to power infinity. Okay, this is infinity. Yeah, then all over 3 raised to power infinity over 5 raised to power infinity. 5 raised to power infinity. Okay, and then minus 5 raised to power infinity over 5 raised to power. There's no point putting infinity here because this is 5 raised to power n divided by 5 raised to power n. They are the same. Okay, when same number divide itself, their result is 1. 2 divided by 2, the result is 1. Or same letter divide itself. Okay, the result is 1. M divided by m, the answer is 1. 10 divided by 10 is 1. Everything itself, whenever a number divides itself, the answer is 1. Or a letter divides itself, the answer is 1. So this one will give us minus 1. There's no point putting infinity there. So we have minus 1 here. Okay. Now, having established this fact, it further gives us, this is 3 times 3 raised to power infinity. A number raised to an infinity is always, the result is 0. Even if the number is being divided by infinity, the result is also 0. Let's just say 1 over infinity, the answer is 0. Let's say 2 raised to power infinity, the answer is also 0. So you need to know this. It's a rule you must know. Okay, so which means that this one automatically becomes 0. Becomes what? 0. That is 0 over 0, because 5 over infinity, 5 raised to power infinity is 0. Then minus 5 times, okay, 5 raised to power infinity is also 0 over 5 raised to power infinity. Okay. Oh. Sorry. This one is 5 over infinity over 5 over infinity. Sorry. 5 over 5 raised to power n over 5 raised to power n. So the answer is also, there's no point putting infinity here. Okay. This is 5 raised to power n over 5 raised to power n. Because they are the same, there's no point putting infinity there. So it's as good as 1. This one will cancel out. This one will cancel out. Cancel out, giving us 1. So it becomes 5 times 1 is 5. Okay? So that's 5 times 1, 5. This one becomes 5 times 1, 5. Okay. So that is for the numerator. We now go over to the denominator. This is 3 over infinity, which is 0, over 5 over infinity is what? 0. Then minus 1. At the end of the day, you find out that 0 over 0 is 0. 0 times 3 is 0. So everything here now has become 0. You are left with minus 5 times 1, that is minus 5. This one is minus 1. Over, we come to the denominator. 0 over 0 is 0. 0 minus 1 is minus 1. So at the end of the day, we are having minus 5 over minus 1. What is that? Plus 5. Answer. Plus 5 is the answer. So I want to believe we've been able to find value from this simple explanation. Don't forget to subscribe to my YouTube channel, share my link of my YouTube channel with other students out there. As your life is being touched academically, make sure you're touching the lives of other students. Thank you.